Welcome to lesson 8.7. This is the last one in chapter 8. We are going to be dealing with the topic of solving inequalities to end this chapter. You received a blue note page. You're going to fill out your table of contents with the title, Solve Inequalities. I'm on page 86. And all you have to do is trim down the paper so that it fits into your notebook page and glue it in, and you're ready to go. At the top of your page, you have some blanks in a box. We're going to talk about the main ideas of this chapter and what we're going to be asked to do. The first thing we're going to be asked to do is actually write our own inequality. You can fill that in. Sometimes the inequalities will be given to us. If they are given to us, we don't have to do this first step. We can just do the second step, which is to figure out the solution to the inequality. And so we are going to always have to solve before we do the last step, which is to graph. So write an inequality if we have to. We're going to solve first, and I'm going to show you how to do that, and then graph after. So one way to explain this is to just try an example together, and I'll walk you step by step through how to do it. So the directions say to solve this inequality. And this inequality looks a lot like what we saw in chapter 7, but the only difference being there's no equal sign anymore. Instead, there's, for this one, a greater than or equal to symbol. We're going to treat it just like we did in chapter 7 with our inverse operations. You notice that was in the box above. So we have to solve for x and want to get x on one side being greater than or equal to a number on the right. Then we're able to graph it on a number line. So we have to solve first, graph last. We get rid of this, and now let's deal with how to solve. How to solve involves writing down the inequality. So let's do that. X plus 7 greater than or equal to 10. Symbol by symbol, copy it down. Second step, we have to get the variable alone by itself so that x is greater than or equal to something. It's not right now, it's attached with an addition of 7. Just like in chapter 7, we need to use the inverse operations and figure out how to get rid of that addition of a 7. Inverse operation of addition, subtraction. We are going to subtract 7 from both sides of the inequality, just like with equations. With inequalities, you have to take away the same thing from both sides. This is what it looks like. If you like splitting it in half, you can. I'm not going to bother with that line because I want to make sure I'm going to put this symbol at the end. I'm just simply going to subtract 7 on the left and on the right. I'm still going to draw a circle around this addition of 7 and a subtraction of 7 because that turns into a 0, which will leave me an x on the left. That's what I want. X is going to be greater than or equal to, notice the symbol is the same, and then we do this subtraction and we have a 3. Once we have that inequality where we have a variable being greater than or equal to a number, then we can come over here to our number line and do exactly what we did in the previous lesson. We're going to graph it. Starting with our numbers, we're going to put a 3, 2, 1, fill them in. And now we're going to practice that open circle versus closed circle way of graphing. Since it's greater than or equal to, I'm going to draw a closed circle on the number line right above the 3. Then I have to figure out where to shade. I want x to be greater than or equal to 3. So that means if I plugged in a 4, 4 is greater than 3, so I know I need to shade to the right. One example done. Example 2 is exactly like example 1, except for there's a different operation. Go ahead and try it first. Remember, inverse of subtraction is addition. We're going to have to add the same number to both sides of the inequality. Write down the inequality first. I'm going to add 3 to both sides. This goes away. It's a 0. I'm left with x on the left and 11 on the right. I'm going to go over to graph it, fill fill in my numbers. This is just x is less than 11. So I only need an open circle, and I'm going to shade to the left. Because if I plugged a 10 in, 10 is less than 11. Here's my giant arrow to the left. The next two examples don't have the same directions. They just have an inequality, but we're going to do the same thing. We're going to solve and then graph. Here's a division one. I'm going to walk you through this, and then I'll let you try the multiplication example number 4 on your own first. This is not written as a fraction. I'm going to rewrite it so that I have my y in the numerator and my 3 in the denominator. And that's going to be greater than 9. Remember, the division and multiplication are inverse operations of each other. Oh, fun. Flip these around. There we go. In order to get rid of this division, I need to multiply both sides by 3. I know I told you that you could cross multiply. Be careful when you cross multiply that you're going from the bottom up diagonally so that your numbers stay on the same side that they're supposed to. So that's my only warning when you're doing the cross multiplication. I would prefer to do the multiply by both sides. I'm going to multiply by 3 on the left and on the right. When I do this, 3 divided by 3 is 1. I'm left with a y being greater than 27. Once I have a variable being greater than 27, I can come over to my number line, put my numbers on. So I'm concerned about 27, not 9. Common mistake is that kids just look at this and they think that they have to use the 9 or the 3 as their starting spot to put the graph on this number line starting at one of those numbers, and actually that's not the case. That's why you have to solve first and then graph. Because we're dealing with just greater than and not greater than or equal to, I need an open circle above 27, and then let's test it out. If it's 28, that makes that statement true. 28 is greater than 27, and so I need to shade to the right. To make sure it's very clear that the right-hand side is darker. Last one is involving multiplication. Remember, to get rid of multiplication, use the inverse operation of division. Carry down the less than or equal to sign and try to graph it. Try it on your own, then resume when you're ready. I've written the inequality. I'm going to divide both sides by the coefficient of 2. When I do that, 2 divided by 2 is 1, and I'm left with n being less than or equal to 13 when I actually divide. Now I can come over here and take my 13 and plop it onto the number line, put my other numbers around it, and begin to graph. This is less than or equal to, so I need a solid closed circle above 13. Now let's figure out whether it's to the left or right. I need n is less than or equal to 13, so that means the numbers have to be smaller. I picked 10, plop it in here. 10 is less than 13, so I have to shade to the left. Voila! So all of the examples so far have not required us to write our own inequality. They just gave us the inequality, we had to solve and then graph. The last two, we actually have to come up with the inequality. It's a little bit harder. We're going to work them through, and then you're done. Quintessa is making bags of party favors for each of her 7 friends attending her birthday party. She does not want to spend more than $42 on the party favors. Write and solve an inequality to find the maximum cost for each party favor bag. Let's dissect this word problem. We want to pay attention to the important things. I know Quintessa has 7 friends that she wants to invite for her birthday party. That's important. I also need to recognize that she does not want to spend more than $42. Can she spend $42? That's the question that you have to ask yourself to decide whether we want the or equal to part of the inequality. And the $42 is also important. So we want to find the maximum cost. That'll be our variable. So we have some pieces in place. We have that there's 7 friends. We don't know how much each bag is going to cost, so that's our variable. Let's define that right away. C is going to be the cost of each bag. And we know our total can't exceed $42. It can be exactly $42. That's okay. She has enough money to do that, but she doesn't want to go over that amount. So that idea of not exceeding or not going over, she does not want to spend more than $42, lets us know that we need the less than or equal to symbol. So let's start to build this inequality. We know that it's got to be less than or equal to. What's the maximum? Is that $42. I'm going to put that on the right so that I can put my variable on the left. It's easier for us to think about inequalities when we have the variable first. Obviously, we can switch it around, but then you have to be careful about your inequality symbol that you use. So let's figure out the left-hand side. 7 friends need a party favor bag. That party favor bag is going to cost C. We don't know. But to find the total, we can take the cost and multiply it by the 7 people that are going to need those bags. So here's our inequality. Step 1 done. Now let's move on. Step 2, actually to solve this, we can divide each side by 7. The C is going to stay there because this goes to be a 1. Our symbol gets dropped down, and 42 divided by 7 is 6. This is what we end up graphing. So we don't have any 42s at all on here. We're going to take the 6, put it on the number line, fill out some numbers around it so that it looks like a number line. And now let's do our circle and shade. There's going to be a solid closed circle above 6, and then we're going to shade to the left, meaning we can't spend more per bag than $6. We could spend 5 and save some money. We could spend 4. We could spend 2. We could spend $1 and get one thing, or maybe 4 lollipops per $1. But the maximum we can spend on each bag and not go over that $42 is 6. So go ahead and try this one first, and then resume when you want to check and make sure you did what you were supposed to. Mark up your word problem with the important keywords and numbers, write an inequality, solve, and then graph. So this one's about Eileen wanting to buy pizzas for her Spanish club. She's given $45. She can't go above that amount. We know that the Mark's Pizza charges $9 for a cheese pizza. I wrote this word in quotes because whenever you see a price of something and then you're talking about multiple of whatever it is, in this case it's pizzas, multiple pizzas, we need this idea of each. Each pizza is going to be that $9. So that's going to clue us into the multiplication that we're going to need to use for an inequality. And again, Eileen wants to know how many pizzas can she buy for that amount, but not going over it. P is going to stand for the pizzas. How many pizzas can she buy? I know that each pizza costs $9, so I'm going to have to multiply the pizzas times 9 to get a total price. I don't want this total to go above $45. So that means this has to be less or equal to that 45. So whenever you're having a maximum, you want to have whatever your variable is either equal to the other side or less. We have our inequality. Now let's solve it just like we did for example 5 by dividing by the coefficient. 9 divided by 9 is 1. The number of pizzas can't be greater than 5. You can buy 4 pizzas, you can buy 3, 2, or 1 pizza and still have enough money, but in order to not go over or to not exceed the $45 you have, you can only buy up to 5. So that's why I'm going to start with my 5 on my number line. Because this is less than or equal to, I need that closed circle because I can buy 5 pizzas. That's probably what Eileen should do so that you have enough for everyone. But then you have to shade to the left, showing that there are more options than just spending all of your money and getting 5 pizzas. So that's how you write, solve, and graph inequalities. again, culmination of this inequality part of chapter 8. I look forward to working more with you in this skill tomorrow. Till then, so long. Bye.